Okay. Yeah, so today we're doing demo 2, which is a continuation of what we did last week, in terms of databases. So the general narrative of the course so far is that last time when we programmed assignment 1, right? How did we store our data? We stored our data in Python dictionaries, which as we talked about last lecture, and you might have already seen just working through the code yourself, isn't a very good way to store data, right? Because it's not persistent and the retrieval might not be the best. Like when you try to do Postman, again, sort of after restarting your app every time, anything new you added into your quote unquote database would get removed. Obviously, we wouldn't want that in a real app, which is why now we're using an actual database, SQLite 3, more specifically, to actually store our data. So now today we'll be going into the same code again, in terms of building our to-do list app again. But instead of storing all of our tasks in a Python dictionary, we'll instead store them using commands from SQLite 3. Okay. Does anyone have any questions about the general idea of what we're gonna do today? Okay. If not, can everybody go or yeah, just go onto the backend course textbook, and then find the starter code for today. I'll give everybody a few minutes to look it up and download it. Once you download the starter code, you should see that difference between today's starter code and code that you've worked in the past weeks is that there's a new file called db.py. And we'll be talking a little bit about how to use this and essentially what it means. Oh, and yeah, just also a heads up as you're still looking up the starter code, if you are, you can, if you have any questions, you can feel free to ask. You can either come up to one of the TAs up here or raise your hand, and one of the TAs might go and help you. Just as you're following along the demo, just so everybody's on the same page and you don't fall behind. Okay, does anyone need more time to get the starter code? Okay, if not, let's just jump into actually understanding the starter code. Oh, that's annoying. Okay. Can I already see this? Okay, so today we're working with 2 files instead of 1, right? So we have app.py and db.py. App.py is already what you're mostly familiar with. It should look very similar to what we had the last time around for both PA1 as well as the first demo. But the new file today is db.py, right? So let's take a look on this side, db.py. So db.py is essentially the file that you would use to interact and manage with your database. So now we don't actually have to store all our information in app.py in Python dictionary like we did before, but we instead have a database and we use functions in db.py to query, retrieve, or manipulate this data in our database. So let's go over a little bit about what each thing in db.py kind of means. So first we have import OS. That's just importing your operating system. We don't particularly use that a lot in this file, but essentially it just kind of helps with the operation of the file. Then we import SQLite 3. If you remember from last lecture, SQLite 3 is just the database that we're using. One quirky thing about SQLite 3 is that it stores your data in a file. So every time we run our app, we might see a new file appear here on the Explorer. That'll be our database for the specific app that we're running. Okay. Here, a singleton is essentially something that allows us to only define one instance of a particular class. In our case here, we only want one connection to the database, which is why we define the singleton function. And then later down here, we pass our like database class, which is database driver, into the singleton function. You don't always necessarily just want one connection to your database. For like larger scale apps, you might want like concurrent operations running on a database, but that's beyond the scope of this course. Just for now, like we just assume that we always want one single connection to our database, and this singleton function kind of allows us to ensure that. Next, the database driver class is essentially, you can think of it as just like the class for our database, right? So we'll be writing all of our functions to actually like manipulate data, retrieve data, query data under this class. And we'll be importing this class into the app.py file to essentially call functions from our database file. Basically, you can think of this as the class that just like actually like connects to the database. And then here, the first function in like the database driver class is init, right? So if you might remember from 11.10, for just like object-oriented programming, you want to like initialize a class in Python. This is essentially like the function that would do it. Okay, so yeah, before we jump into, I guess, like the code, does anyone have any questions on the setup of any of these files? I'll just move it on this side real quick. Okay, no questions? All right, let's jump in then. Okay, so just a thing to note before we actually like start coding. So now you have like two files, right? So you kind of might be wondering like, oh, which file should I like start my programming on? Generally, it's a good rule of thumb to like know the layout of your data before you try to start even like retrieving your data or manipulating your data. So it's probably a good idea to like set up your tables first before you write any functions in like app.py, right? So it would make sense to like initialize our database first. So let's start with this function. So yeah, let's write some documentation here. Okay. Wait, I'll just make a new line so you guys can see everything. Okay. Okay. So essentially, we want to use this init function to actually like start up the connection with the database and store it in a particular variable. So for today, the variable that we'll be using will just be called con, short for like connection. So self.con is equal to SQLite3.connect. So I guess like as the syntax kind of implies, we're just connecting to our database, right? And first we want to give, I guess, our database a name. So since we're making a to-do app, we'll call it todo.db. And then we want to have this particular field called check same thread equal to false. So essentially what check same thread does is that it only allows like one thread, or setting it to false would only allow like one thread to access the database at one time. It also has to do with like multiple operations happening on the database at one time. As we kind of mentioned before, since we only wanted to limit it down to one for the purposes of like our app here, we just set it to false. Okay. Does anyone have any questions so far? All right. The next thing you want to do in the initialization of your database app is actually something a little bit quirky. So you actually want to like delete the task table first. So let's just assume that we'll be making a table called task, right? You actually want to delete this table first before you actually like create the table. But as we know, like I haven't programmed any of these particular functions yet, but it's something that we'll be programming like next. The reason why we want to like delete the task table first is just in case we get the error that like when we restart our app that the task table already exists or something, we just like get rid of it first to like restart it all over again. Okay, does anyone have any overall questions about init? Oh yeah. Yeah, so you not for the like any time in this course particularly, but if you want like concurrent operations happening on your database, so like multiple threads being able to like query data in the database at the same time, I think that's when you would set check same thread to be true for like larger scale applications. Yeah.
So there wouldn't be any error if you like deleted a table that's not there.
There shouldn't be an error if you delete a table that's not there, because we're only creating the like one table, so we are deleting the table that should have already been created should there be like a table there. Oh, on the first initialization, there actually wouldn't be an issue. Yeah. I think that's because when we implement delete task table, you'll see a little bit later, we do that like funny thing at the end of last lecture where we do like delete table if exists. So we ensure it doesn't happen. Yeah, any other questions? Okay, so now let's actually like make these functions, create our task table and deleting our task table. So create task table takes a field self. Let's write some documentation. Using SQL, we create a task table. Okay, so here we'll use a try except block. For anyone who's like not entirely familiar with what that concept is, it's just like we'll ask Python to sort of do something for us. And if it throws an error at us, we'll catch the error. And essentially we'll print out the error so that we know what it is, so it's easier to debug. So try. So here, when we want to create our table, right, this is like the part where we actually start essentially like using SQL commands in our code. So we do self.con.execute, which just essentially like asks it to execute like a particular SQL command. And we'll do, we want to give it the SQL command in a string. So create table. This is all from like last time when we talked about SQL commands. So when we create like a table in SQL, we do the keywords create SQL task, ID, integer primary key. Remember, we want this thing to like auto increment so we don't ever reuse any old like IDs. Then the description is text not null. And then done is Boolean not null. So does anyone remember what like the not null field essentially does? Yeah.
It makes sure you always like have a value there.
Yeah, exactly. So like we can't like have an empty value in that particular column. I remember from last time as well, we ended our SQL queries with a semicolon. So we just put a semicolon at the end there. Last time something I didn't make super clear was like the usage of commas. I did like forget a comma at one point, but essentially you just want to use these commas to separate out your columns. So ID is a column, description is a column, and done is a column. Okay. And then the last part is just like exception as E. So in the case that it throws us an error, we give it a variable E, and then we print E. Any questions?
Yeah.
Is there a way to set like a default value?
There should be a way to set the default value to a column. I don't think I have the specific like syntax for that off the top of my head, but usually you should be able to, or like there should be some keyword that allows you to set a default. Any other questions? Okay, so let's just finish up the delete task table. Give it some documentation. Okay, and then similarly, we just want this con variable to execute a SQL command for us. So we self.con .execute drop table if exists. So if you remember, drop table if exists will only like drop the table. Well, first check if the table exists before dropping it, so you don't get any kind of error. Okay, are there any questions on creating or deleting a task table? Okay, so that basically does it for our init function. Now we can move to app.py. Okay, so for app.py, the first function here is to get all tasks, right? If you remember from like them or from Reddit or from the last lecture, we wanted to like get all of the things in our specific database. So here we would probably need like another function in our like database file to like help us do this, right? But before we do that, let's go up here and like import some things. So first we need to import the database file because we want to be able to call functions from our database file. So we first need to import it so we can access all of these functions that exist, right? And then let's set up an instance of the database. So db equals db.database driver. So this is essentially creating it like a version of this database driver object in our app.py file. Okay, so we want to get tasks, but we can't get tasks here before like programming another function in our database that actually like would retrieve all of these potential tasks for us, right? Because our data is no longer in the app.py file. So let's do one more thing in the db file. So let's do def get all tasks. That takes in self. Do documentation. Okay, so here, what we want to do is we want to execute. So does anyone remember maybe like the SQL command that we would want to execute here? Yeah, exactly. So we want to get literally like everything from the tasks table, right? So the thing we want to execute is select star from tasks. But when it returns something, we want to store that in some kind of like variable so we can like manipulate it. Let's just call this variable cursor for now. Oh, and then you need the semicolon. But the issue here is that whatever like SQL returns to us, it's not very like well put in terms of a Python format. So we need to actually like iterate through this cursor to like make it more Python sort of like accessible. So if you go into here, this is like essentially like what it would look like when you first return it from the database, right? So you have like the way it returned it to you is a 2D array in which like I guess like a more like image friendly version would look like this, right? You would have like the task ID as we kind of outlined when the creation of our table. You would have like the description and you would have a Boolean here, which I wrote as 0 or 1, to be whether it was like done or not. But we need to like process this to make it more Python friendly. So what we'll do here is we'll set up an empty list. So tasks is an empty list. And then for row in cursor, tasks.append, we want to make this into like a dictionary because usually we want all of our kind of like responses to be in dictionary. So ID is row at 0. As you see here, the ID is like the first entry in the row, right? Description is row at 1. And then done is row at 2. Okay. So after that, then all we need to do is essentially return tasks. Oh, there's one other quick thing you need to do here. So this done here needs to turn into a Boolean. So just make sure to wrap a bool around this. Yeah. Does anyone have any questions on that? Okay, so then this function here that we implemented into the database file essentially correlates with exactly what we want to do in the app.py file, right? So now we can do this get tasks endpoint in the app.py file. Can everybody see this okay? Okay. I think should be visible, but just let me know if it's not visible. And then return JSON. Remember, we want to like dump this into a JSON as a response. And then so tasks db dot get all tasks. And yeah, and then we give it a status code of 200. Okay. Anyone have any questions there? Okay, if not, let's start up our app. So Python 3. Oh, so first, going through the process of like making a virtual environment and stuff. And then okay, then we can run our app. Okay, let's go into Postman. Make a new collection. Name this collection demo2. Add a request. Take this address here. Here. Okay, so when we hit Postman, we see that there's nothing that's been added into our database as of yet, so we get an empty list for tasks. Do we have any questions? Oh yeah, the starting of them. So the command I do is like source vem/bin/activate. Although I think you can also do like period vem/bin/activate. This is for Mac. If you're on Windows, I'm pretty sure it's a vem like \script/activate like this. Okay. There are no further questions on this. Let's go to the next one. So next, we want to, now that we were able to get all tasks, we now want to like create tasks, right? So now let's go back into our db file and try to program up a tool that will help us create a task. So to create a task in your database, what you essentially do is like inserting something new into the task table, right? So let's call this insert task table. Okay. Give it some documentation again. All right. So does anyone remember like the SQL keyword for literally inserting something into a table? I think I just said it, but yeah. Yeah, it's insert. Okay. So now we want to like tell SQL to like insert something for us. So we'll do something very similar. So we want to insert into description and done and some certain values. Oh, but wait, there's like a problem here, right? When we want to insert into like our SQL database, we have to like tell it the things that we want to like put in. So this function actually needs some like other parameters in it as well that we provide to it, right? So we need to give it a field for description and a field for done. So here, the particular SQL command you use, so you're inserting into task. This is again specifying the columns that we're inserting into. So description done. And then the values that we actually want to insert into it, because we're like taking something in from the function itself, something we're providing, we want to give it a tuple of like question marks, just to like for syntactically indicate to it that we're going to be using the parameters given to it in our function. So after the question marks, you need a semicolon to end your SQL query, and then we give it description done. If anyone's not familiar with the concept of like a tuple, essentially it's just like you can think of it as like a list, but with like a fixed length or something like that. So essentially we're giving it a tuple with fixed length of 2, since we only have 2 fields that we want to give it, a description and done. Okay. And then after that, this is something new. So now we want to like, because we've added something into our database, we now want to like save those changes that we made, right? As opposed to like a get function where you're just telling the database to like give you things that already exist in it, we've created something new in it, so we have to make sure it stays. The way we do that is self.con.commit, which essentially saves our changes in the database. And then finally, okay. Note that like once we execute this SQL command as well, it also like gives us back something. It doesn't just like give us like the whole, or it gives us something that we need to like sort of like process, right? So we do the same thing where we set the cursor variable to this first line that was written here. And then finally, what we want to return is cursor.lastRow ID. The reason why we want to do this is we want to get the ID of the newest task that we've inserted into the table. So when we insert into the table with the visual representation here, essentially what happens is you make a new blue bracket pair, right? And since we want the last ID of the newest thing that we put in, we give it this we just want the field of last row ID. Okay, any questions here? Okay, if not, we'll be going back here and creating a task. Okay, so let's give it some documentation. Okay, so very similarly to what we did in the previous demo, as well as in the previous assignment, we still need to load in some information, because when we're creating a task, again, we're passing it in some information. We're telling them what the description and what our done status is. So we need to turn that from a JSON into a Python dictionary. And remember, the way we do that is body equals json.loads request.data. And then the description is body.get description. And then done is body.get done. I guess we don't actually, body.get done isn't entirely necessary, because we've made the assumption that every time we add a new task into our database, it's defaulted to false, given that obviously you probably haven't started the task yet. But hypothetically, if it was a different field, you could just keep getting this field like that. Okay, so now we need essentially the task ID. The reason why we need the task ID here first is so we can actually return that particular task once, return that particular task as a JSON back to the front end when we're done with it, right? So you remember how in the last assignment and in the previous demo, when you posted a Reddit post, or you posted a task, we actually show that task that was created at the bottom of your Postman, and that's essentially what it's going to do here. And because we've made it such that our function insert task table actually gives us the ID, we can just call that, right? So task ID is equal to db.insert task table, and then we give it the parameters description and then false, since we are assuming that our thing hasn't been completed yet. Okay. Then, like I mentioned earlier, the next step in our logic here is that we want to use this ID to actually find the task that was newly inserted. But the issue again here is that we don't have a particular function that does that for us in our database file. So now we'll be jumping back into our database file. Okay. Since we're jumping between files, does anyone need some time to catch up or anything? Oh yeah. Wait, how do you get rid of the explore? Oh, that. Okay, is this better? Okay, cool. All right. So yeah, let's get. Oh, there's another question. Oh yes, the other window. Like this?
Yeah.
Okay. Is everybody good with this? Okay. Just for clarification, we're working in the database.py file right now. If anyone. Okay. So back to the database.py file. The next step in the logic is that we want to be able to, given an ID, right, actually retrieve the task itself. Again, the reason why we need this is because when we insert a task, we get the actual ID of the new task we inserted, but we don't have the entire task itself. So that's what this function is essentially going to help us do. So get task by ID and self, and because we're providing it an ID, right? As sort of the logic of the function implies, we would want another parameter called ID. Okay, So the logic for this function will be quite similar to the first function that we programmed here in our database table, right? The one where we just get all of the tasks. So let's just start by using this as like our starter code. Okay, so instead of select star from task, all we need to do to get like a particular task is to add a where condition, right? Remember how the SQL keyword where allows you to specify a condition? So what SQL spits back to you meets that condition. So select star from task where ID equals question mark, and the question mark is something that we're going to be providing it, right? And then here again, what we need is a field for a field for the ID. So here, instead of a tuple of size 2, you want just like a tuple of size 1. So essentially, you still need the comma just to specify that like, or just to indicate that it's still a tuple, but of size 1. Okay, so we don't need the task list anymore, right? Because we're only getting like essentially like one task back. And then we still do need the for row and cursor because we are still getting like some kind of like a nested list back, but we don't need the task.append. So we can just return this. And then supposedly this doesn't actually like work out and we don't get anything. At the end here, we would just return none. Okay, does anyone have any questions so far? Okay,
Yeah.
oh yeah,
Wait, did you remove the parentheses?
the parenthesis. Oh, yes, thank you. Okay, so yeah, hopping back to app.py. So following our chain of logic again, right, we inserted this new task and we get the task ID back. Now we can actually like get the task itself. So task equals db.getTask by ID. And then we give it the ID, right, which is task ID. We want to check if this task actually exists like we did before. So if task is none, then we return a JSON that tells us like an error. So JSON.dumps. With an error code of 400. Otherwise, if it's not none, we can just return the actual, task that was created. Okay, any questions? Alrighty, so let's go into Postman and then test it again. So we'll make a new post request, and I think it's tasks. Oh, yeah. Okay, so we'll give it a body. Just say demo 2. It doesn't, since we don't actually care whether it's done or not, it doesn't really matter. So is the app running? It's not running. Okay, so here when we send the actual task, we see that it's been created, right? Down here, I'll do demo 2 and description is false. So let's just change this name. Okay, so if we go into here and get all tasks again, we see that it is now in our database and we can retrieve that task. Anyone have any questions so far? Okay, if not, the last couple of things that we need to do is just update a task and then delete a task, right? So for updating a task, let's do that first. Again, we need another function in our database. Oh, okay. actually, let's do this one first. So get task. This one gets a specific task for us first, right? So just go back into the app.py file. And since we already basically just created a function in our database file that gets us a specific task by the task ID, we can just utilize that here, right? So let's give it some documentation. And then task is db.get task by ID. And then we pass it in the task ID. Task is none. Again, we want to check if it's none so we can return an error if something, went wrong. So this time, instead of like something went wrong while making the task, it's just like we didn't find it. So we give it an error code of 404, right? If it does exist, we just return it. Okay, let's try this out again. Let's just say like the endpoint here is like /tasks, and then we give it an ID. So one should hypothetically exist in here. We can make a new one just in case. Let's just say edit demo2. Oh, did a new one not get created? Okay. I think there's 2 in here now. Okay, so we have edit demo2 and delete demo2, right? Let's just say we want number 2. We have delete demo2. Okay. Any questions? Okay, let's just quickly move on to updating the task and then deleting the task. So since we have like an update task and a delete task here, and there's like a specific SQL query that we can just write to actually update tasks and delete tasks, essentially we just want to write 2 more functions in our database file and then call them in these 2 functions here in the app.py file. So what we do is just, okay, let's just say update task by ID, self, ID, description, and done. Since we're updating the task, we do want to like provide it some new information, right? So we need parameters in our function here. We're updating the task by ID. And then we just want to execute a SQL command. If we remember, the SQL command for updating a task is update task, and then set description equals a question mark because it's something that we're providing. Done equals a question mark because it's something we're providing. And then where the ID equals a question mark because we want to specify to only update the particular task that aligns with that ID. End it with a semicolon. And then provided the tuple here that's a size of 3, description, done, and ID. Okay. Oh, does anyone need this? Like, okay, I just make this bigger. And then after we've executed that, since we don't actually want to like return anything here, we're just updating something on database, we can just save essentially what we made, right? Okay. And then now let's hop back into app.py. Here we just want to essentially call that function that we just made. Because we are again passing something in, we do need the body. Body.get description, done. Body.get done. But this time we actually do need the body.get done, right? Because it's possible that we're updating the done status of our task. And then we do want to turn this into a Boolean. Okay, so then we just call this function that we just made essentially, and give it the description, or give it the task ID, the description, and then the done field. Okay, but again, the issue here is that like similar to when we like create a new task, we don't actually like get the task itself, right? We essentially just update something in a database, but nothing is returned to us. So we need to get that task by the task ID to actually like output it to the front end. So task is db.get task by ID, task ID, similar to what we did when we created a task. And then now here, if we just check if the task is none, then we return an error that it wasn't found. With a 404 error code. And if we do find the task, then we json.dumps the task with a 200 code. Oh, I did not return this. Does anyone have any questions on this? Yeah.
Is it okay if we return something from a task by ID instead?
Yeah, that is potentially a way you could implement it as well. You could just wait. Could you implement it like that? I think you would need to probably call this other function in the database file to actually like return something from that as well to give it to this side app.py. But yeah, I guess like that would be based on your own like design of the two files. Okay, let's give it a try. So this is okay. So we give it a task ID. So let's do 1. And let's just say the body is sleep. Oh, it resaves. Okay, I'll make 2 new tasks again. Okay. Oh, we have 2 in here. And then we can update this to be sleep. And then once we hit all tasks again, we see that like the first one changes to sleep.
So one thing I just want to point out real quick is when we do save the file, it deletes our table and then recreates it. So we're losing that data, and that was one way in which this was supposed to be better from PA1. And so normally you wouldn't do that. Every time you save a file, you're not going to delete all your data. The reason we're doing it here is because when you end up submitting this, we don't want data to still be stored in anything. If you have data in your file, you're going to just delete the table, create it, and that way when we run our test cases, you can actually check it against an empty database. But obviously, normally you don't want to just like save, like implement to save and then lose your data. That's just how we're structuring it in this file here.
I think if you remove this, actually, it might save it.
That'll be fine.
But
yeah.
Okay. Yeah. For the purposes of the demo, pretend I did not implement this line. But yes, I'll just finish it real quick. Okay, so last thing is we're going to delete the table. So delete task by ID. Here we don't actually need to give it anything except the ID. And again, we just want to execute the SQL query. Delete from task where ID equals the question mark, the thing that we're giving it to, or giving to it, and then ID. Since there's nothing else and we're making a change to the database, we just want to self.con.commit. Then lastly, we can go over here to delete task, and then do the same thing essentially. So task is db. We want to first get the task to just check if it even exists in the database first. And then if task is none, then we return the error. And then do the delete. So remember how in the past, even when we deleted a task, we just wanted to like return it to like show which task ended up getting deleted. And that's essentially what this line is doing here. Okay, wait, I wonder if I comment this out, if it'll be okay. Let's just test it really quickly. Okay, so we make 3 new tasks. They're here when we get all the tasks. And then let's delete the task. Let's say we delete the first one. Get task. Maybe. Hopefully all the tasks are still here. Okay, so this time when I remove that line, it seems that all the tasks are still here. So that should be good. This is our delete task endpoint. So here, when we actually like run it through, we see that the task that we want to delete is returned to us, but then when we run get all tasks, it goes away. Cool. Anyone have any questions? Okay, just clarifying on this like first line here. Yeah, as Mateo was saying earlier, when you run the test cases, you just want to like remove the table that you already have, so all of the test cases can run with an empty database. But if the when you're actually like first instantiating the task table, you would, I guess, like want to just create it in the first place. Okay. If there are no questions right now, we'll just run through the Kahoot very, very quickly. If you have to go, that's okay. Just put your net ID down.